First of all, let me know who out there are web developers. Good, that's a good number. That's about half. So you're going to love this section because it's going to tell you all the new stuff. And then for all of you XAML developers, you should pay attention too because these are the features you'll see in XAML 6 years from now. Everybody wins. All right, so when we go out and we talk to developers, we hear a lot of feedback. And whenever we were working on the feature set for Windows 10, we were trying to bring some of the most common asked ones to the top. And so what we've found is that developers in general ask us for more interoperability. They hate it when they have to write code twice. In the web, we're supposed to write once, run everywhere. So they want the code to just work on every browser. The second thing that we get a lot of requests for are new features. Developers want to see new specs from the W3C implemented. They want to see new innovations in the web space so that you can do more inside the browser. And third, they want to see the boundaries between what we do in the web and what we do in the app space disappear. They want to be able to take that same app development environment they have for the web and use that to build store applications. So that's what we're going to talk about today. First of all, more interoperability. I've got a big number here, 44 billion. Can anyone guess what 44 billion represents on the web? Sir?
Maybe the amount of browsers or devices that are using the web?
Not quite, but close. It's 44 billion websites that's crawled every day. Now, you may know we actually at Microsoft have our own search engine. It's called Bing. You've heard of that before? All right, good. Good to hear. So it's actually quite beneficial for us to have Bing because it goes out, searches the web every day, and indexes the pages and the code on the pages and gets to look at them and see how they're written. Now, in addition to that, we also have trillions of URLs that we crawl every day. So we get a lot of data. Now, when we think about interoperability, we want the web browser to be able to render all those trillions of pages properly. But it's quite difficult to say that we're going to go and make it work on those trillion of pages. But what we've been able to do with the data that we get from Bing is we're able to find common patterns that developers use. And you notice patterns, it may not mean that they're writing to standard. It may mean that they're doing something else, but they're all doing it the same way. And we figured with Edge, we can make that work too. So that's where the interoperability comes in. Finding those patterns that web developers are using and making sure that they work for users. Now, to make sure we have context here, I want to go back 20 years ago to when Internet Explorer was first released to the market. And for those of you who don't understand how long ago 20 years was, this is what the world looked like. It was an awesome place. So that's how old Internet Explorer is. Okay, it's been around a long time. Now we're going to skip ahead to Internet Explorer 6 because in that time period, you can imagine the web did not change as fast as it did today. You couldn't deploy an update every time a small change is made to a browser. So it was very important that when we released new versions of the browser, we didn't break the web. We wanted to make sure that changes in the browsers remain compatible with the code that was already out there on websites. So in Internet Explorer 6, we introduced, based on a new doc type, a rendering engine that would render the strict mode, and then we also maintained Quarks mode. And how we did that is we looked, and it's basically an if-else statement. If there's a doc type on the page, you render in strict mode. If there isn't, then you render in Quarks mode. Well, as time went on, we continued to add new doc types. We continued to add new rendering engines. And we continued to add new rendering engines. And continued to add new rendering engines. When we got to IE11 and realized the number of different rendering scenarios that we had to take care of with Internet Explorer 11, we realized that we couldn't move forward at this rate of backwards compatibility while still delivering what developers are asking us for, to move faster, to work better across sites, to deliver new features. And so that's where Edge came in. Edge is going to be our new browser for the future, for maintaining future compatibility, and Internet Explorer will be in place to handle the backwards compatibility and the traditional rendering. That way, when you come into scenarios that don't work on the modern web browsers, and we know if any of you work for large corporations, you might be stuck in an environment that requires an old version of Internet Explorer, we'll still have IE11 to support that. Now, as a web developer, this is what our world looks like. We have tons of different browsers that we need to support. This is a screenshot from BrowserStack of all the different features that you have to test today. And you can see all the different versions of Windows with the different versions of Internet Explorer that run on them. It's quite a task for a web developer. Now, having the different fractures of a browser isn't actually a problem that is just Internet Explorer. A few months ago, QuarksMode did a study of the of the currently used phones and the version of Chromium that they use. And Chromium is the open source engine that runs Chrome, the browser. They found out that after every device maker made their own version of the browser with Chromium that never got updated, less than 40% of users who were buying phones today got a new updated version of Chrome. Now you can imagine for a web developer writing for mobile, that means that you not only can support the latest version of Chrome, but the last 8 or 10 versions as well. So Microsoft Edge is here to make our life better on Windows. It's a universal Windows application, which means that it's going to run across all of the devices in the Windows family. Everything from a PC to a phone, down to a HoloLens and an Xbox. Edge will always be up to date. So that means we don't have to wait for an OS to be released to be able to update a version of the browser. It has a new rendering engine called Edge HTML and a new fork of the Chakra JavaScript engine that once we removed all of that Internet Explorer specific code, runs significantly faster than what we've had in the past. Now, these same engines run on all the devices. So that means when you write code and you know that it works in one version of Edge, then it's going to work in all the versions of Edge. Interoperability starts from the first time that we hit a web page. Now, many of you may recognize this. This is the list of user agents from a modern browser. What you might not realize is that everything in red is a lie. Just a little lie, but it's a lie. So, for example, none of them are Mozilla 5.0. Does anybody know what Mozilla 5.0 actually is? It's Netscape Navigator. Netscape Navigator. So, but that's part of the user agent. Actually, in the spec for user agent, it states it should start with Mozilla 5.0. So they all call themselves that, but that's not really what they are. None of them use Gecko. Mozilla is not like is not KHTML. Chrome says that it's Apple WebKit, which it's not. So what you see is that all of these browsers are stating that there's something, and what developers have grown to do is to test based on the user agent string of the browser to determine whether they're going to deliver code or not. But that user agent string is not trustworthy. So with Edge, if you look at the user agent string that we're using there, you'll notice it's almost identical to Chrome's. And we're doing that on purpose because developers who write a page and say, you're Chrome, you get the new version. You're anybody else, you get the old version. We want them to see Edge and give us the new version. And what we've done is we've made changes to the rendering engine to make sure that that page will render just like it does on Chrome. Now, as a web developer, we're still asking you to write to web standards. That's still very important. At the same time, we realize that there are many web developers out there who aren't writing specifically to standards. And we want to make sure, for the user's sake, that all those pages work. Now, here's a sample of what would happen. So we have the Hawaiian Airlines here, and you can see that their page specifically built to work on an iPhone. On an iPhone, it looks great. It's sized properly. It has gradients. It has icons. If you look at it in Firefox or on a Windows phone, you'll see that you get the desktop version. And on the Windows phone, you get a crammed small version of the desktop version. When we update the user agent with Edge, you'll see that we get the same code that they deliver for an iPhone. Now, at the same time, we now support WebKit gradients. We also support the way that Apple loads icons and fonts. Although it isn't just standard, we notice that they load them differently than we did in Internet Explorer, so we support the way that fonts are loaded for them as well. And then we also support touch events. And this specifically iOS-style touch events, which again are not a standard. We also support the standard, which are pointer events, but we know that when pages are written to an iPhone and use touch events, we can make that work as well. So we map those touch events to pointer events. And what we get for the user is a great experience where the web works and where in the past it was broken. So interoperability is important, but it's also important to be able to adopt new standards quickly. So with Edge, we also have hundreds of new standards and features. In fact, we are supporting over 45 of the new W3C standards just in this initial release of Edge. All right, if we can switch over to number 3, I want to take a few minutes and show you what the type of things that we're able to do in Edge with the new features that we have implemented. The first thing I want to show you is, this morning we showed you the flight simulator, and we showed you a little bit of how WebGL and web audio work together. I want to show you another scenario here. And what I have is I have a 3D setting made with WebGL. This is actually built with a framework called Babylon.js, which is great for making WebGL real accessible to JavaScript developers. Now what you'll see here is when I move one of these elements inside of the circle, we then start playing that sound as well, okay? So I can move them in. And now one of the other things that you'll notice, take them out there, is I'm also able to control the visual state of this page based on the audio. Now with web audio, we're actually able to look at the low-level content of an audio file, which isn't just about the sound, but it's also looking at the sound wave and being able to adjust visual states based on that. And you can see that one of the things that we've struggled with audio in the past is that audio on the web was very imprecise. It was hard to time not just a single file with your view, but especially if you're using multiple audio files that you need to have timed together. But with web audio, that's quite easy. We're able to take the entire array of audio elements on the page and control them separately and simultaneously as well. So web audio and WebGL, and I didn't talk too much about it, but we also have a number of new supported features in WebGL as well. So let's look at another one here. Okay, so this is another WebGL immersive environment here created with a 3D rendering. What we have here is a haunted mansion, I guess you could call it. All right, controller out here. Now, remember this is a web page, so the same type of input support that I have on a web page, I also have in the WebGL world. So I can use touch, or I can use my pointer and mouse. And you can see I can look in through the environment, get really close to see it rendering. one of the other things I can do is I can bring in a gamepad here. So I'm going to go ahead and bring my gamepad control in. I want to show you something that we have that's special in this world. Find it. Here we go. We got a little graveyard here, as every haunted mansion should, right? But we might have some familiar faces here. All right, this first one here you'll see is Clippy, right? We click on him. There he is. May he rest in peace. You ask for it, we give it, right? Next thing, the Shroudender cat. Good looking guy there, but yes, he's dead. And then, of course, right beside him is a special one. You see that there? The grave for IE6. Now, when we click on that one, we'll actually go up here and look what we have here. For whom the bell tolls. Now remember, this is all inside the browser. This is a browser experience. It doesn't require any type of plugins or anything for the user to load. It's all code delivered through the web. Okay, let me show you another one here. Let's show you the code for it first. Go back here. Now, we try to prioritize the features that we implement based on what developers ask for. In fact, if you go to status.modern.ie, you'll see a list of the features that we are implementing and what we're planning to implement next and what we're considering to implement. You can actually go there and vote on them as well. So one of the ones that was highly requested is one called foreign objects. Now, what foreign objects does is it allows us to embed things inside of SVG. So with IE11, we supported embedded SVG. So we have an SVG embedded into a page, and then inside of the SVG, you'll see here we have an iframe, right? So we have this iframe inside of the SVG item. So we were thinking really hard, like, what is this for? What do you use this for? And we actually came up with a scenario that we think will work pretty well to demonstrate it. So I'm applying a few SVG filters onto this iframe here. And now when I open the page, what you'll see this is what we call the drunken browser. Now, I don't know if this ever happened to you, but maybe some of you have gone out for a long night on the town or something. And what's the drinking age here? Is it 21? 19? So it was over 19, I'm sure. And you go out and you have a few drinks and you come home and you use the internet. That's a very bad idea. Don't ever do that. But in case you wanted to, we figured this would kind of simulate the experience that you would have there. So you'll see this is bing.com, and if I do a search for something like Babylon.js, you'll see there it is, and you can click on that and kind of see the results for that, and it's a little tough to click on, just like real life, but there you go. Now, for those of you who aren't yet 19 and have no idea what we're talking about, we have another experience for you. And what I'm going to do is I'm going to switch over and I'm going to comment these out. And then I'm going to uncomment this other filter. So all I'm doing is switching the filters here. Okay? And I'm going to refresh the page. And what we have, this is what we call the Minecraft browser. So inside of here, I'm going to search for Minecraft images and see what happens. So now inside my Minecraft browser, I can look at pictures of Minecraft. It's like Inception. It's Minecraft inside of Minecraft. Kids these days would love this, I'm sure. So there you go. It's a couple examples of how you use foreign objects. But again, it's a highly requested feature. All right, let's go back to the deck to number 1, input number 1. When we implemented experimental features in the past, we've done things like browser extensions, where we say, or excuse me, browser prefixes, where we've said -WebKit or -MS. And we found that it caused quite a difficult time for the web, because developers, we would always tell them, this is an experimental feature. Once we update it, go back and change your pages and take out the vendor prefixes. But they never update their pages. They never take those out. So we've got tons of pages out there with -MS and -WebKit in front of a bunch of stuff. And we don't want that to happen anymore. So just like Chrome and Firefox, we're all switching to a new pattern, which is the flags. And so you can go into your browser in Microsoft Edge and go to About Flags, and you can turn on and off experimental features. We think this is a lot better way, because now it's controlled by the user of the browser, not by the developer of the page. Okay, the final request we're going to talk about is removing the boundaries between the browser and the app world. So we talked a little bit this morning that we have a rendering engine, Edge HTML, that makes up the Microsoft Edge, and we also have the Chakra JavaScript engine. So that's what runs inside of the Edge browser. Well, those same engines are what power the JavaScript apps. So when you're using a JavaScript app on Windows 10, it's using the engine of Edge. So when Edge gets updated, the JavaScript apps do as well. Now you have choices as to how you're going to load content. You can do it as a packaged content, where you take your HTML, your JavaScript, your CSS, and you load it inside of the AppX, and that gets zipped up and sent to the store. Then the user downloads the entire package. So that generally works great offline, because all the code is right there on your computer. The other option that's new for Windows 10, and we'll talk about a little bit today, is hosted content. So hosted content is where you leave that content on your web server, and the AppX will simply point to the content on your site. And that's great because it's always up to date. You publish new content to your website, and the users of your store applications see that. We still have the web view in place, because there's times when you want to mix that content, have some local, have some on the server. Okay, so let's look at packaged content. We have a major innovation in this area that I want to make sure we talk about. We're very excited about the support that we have for Cordova in Windows 10. Not only can we support the different patterns that Cordova supports, packaged, hosted, and embedded Cordova. Embedded Cordova is where you just take a portion of your application and have that be Cordova, the rest of it is native. But it also is built directly into Visual Studio now. So when you do a Visual Studio install, one of the options you can add is support for Cordova development. So that means from Visual Studio in Windows, you can write code for not just Windows apps with Cordova, but iOS and Android as well. And not only write the code, but deploy and debug the code on those devices as well. So it's a great development environment, probably the best development environment for Cordova on Windows 10. The web view also has a number of new innovations in it. First of all, it's using the rendering engine. So again, the web view is always up to date. We have some improved performance in the web view. Not only do we have a faster rendering engine, a faster JavaScript engine, but we've also moved the web view off of the UI string so that when your web view is loading, it doesn't slow down other content of your app. Also improving the communication between web view and native code. That's something that has been difficult in the past, and I'll talk to you in a minute here about how we're making that easy. And then also giving you access to the Windows runtime from the code that runs inside the web view. Right, so this is one of the new APIs that we've added to the web view. It's called Add Application Object. And what it does is it allows you to add some metadata to your native classes. So that can be C# or C++. And then add them into the web view with Add Application Object. And so then the code in your web view will see the native classes as native JavaScript methods. So they'll see your native classes inside the DOM. And what that allows you to do is to skip the bridges that you have to do where you would stringify content and then pass it up to the parent application, do something with it, and stringify content to pass back. Your JavaScript code and your native code can call each other directly. So direct communication between those native classes and the JavaScript code. Okay, I want to spend the next few minutes on hosted content because this is something that we've had a lot of requests from developers for. Developers generally enjoy our JavaScript development environment, and many developers tell us it's the fastest way to run JavaScript code on platforms. But they don't want to have to make changes to the way that they work and they deploy their code. So the hosted apps allows you to package your website or your web app directly in the Windows Store. From there, you can call the APIs, the Windows Universal APIs, from that code, which means everything from live tiles and toast notifications to beacons and low-level audio APIs or low-level HID information. All of that is accessible to the code that's still running on your website. It also allows you to mix native code and JavaScript code. You can add native components to your hosted app and call them directly. You can even have content that's in your package that's a fallback for the code if for some reason the user is offline. Okay, if we can switch back to the demo machine number 3. All right. What I want to do is I'm going to build a hosted app for you, show you how easy it is in Visual Studio. I'm going to start with this application I have. This sample app I've built is called Shifter Connect. And there's a lot of those sites out there, but we're developers, so we really want to meet code, right? So Shifter Connect introduces developers to frameworks. And instead of liking or not liking people, you can like and not like frameworks. So for example, Node.js, I'm going to go ahead and love that. Knockout, going to go ahead and love that. GWT, and so on and so forth. So this would make a fantastic store application, don't you agree? That way you can just have it on your phone and like and unlike frameworks all day. So what I'm going to do is I'm going to turn this into a hosted app. And I'm going to start by grabbing the URL here, and then I'm going to open up Visual Studio, and I'm going to do a new project. So from here, I have a JavaScript project. I'm going to do a blank JavaScript application, and instead of adding code into my blank application here, I'm going to delete code from it. So I'm going to go into the Solution Explorer. Let's go ahead and pin this. And I'm going to find my CSS, and I'm going to delete it. I'm going to take my JavaScript, and I'm going to delete it. Win.js, we can delete it. HTML page, we'll delete it. Delete it. Doesn't want to go. I have no idea what it's doing there. Let's see. Yes, delete it. That's all I wanted to do. Okay, so one thing I'm not going to do is I'm not going to delete my images because I still want the splash screen and the icons for the store to be local because those are the things I'm going to submit in the store that's going to load up before our page does. So from here, I'm going to open up the Apex manifest. I have a start page. And this is something that if you've done JavaScript apps on Windows before, you know the start page points to the local page that you're going to start with. Well, in this case, I'm going to point it to a remote page. Now, one other thing that I need to do in here is I want to make sure that I define the scope of my application. So I'm going to add an application content rule here. And what this rule is going to do is it's going to tell my app what parts should be inside the app and what should be out in the open web. So the first thing I'm going to do is do a match for the URL that we're using. And then I'm going to say the type is to include it. And then this is also where we define the Windows API access. So all. So I've added those 2 lines there, and I'm going to go ahead and load this. And just like magic, Our web app is now a Windows Store app. It's that easy. Now, being a Windows Store app, you get those same great benefits as if you were running the code locally or even building the app in XAML. It's sandboxed, it has its own cache environment, it has access to the Windows APIs, it's managed from the OS level. All the great benefits of a Windows app you get from your web app by being a store app. Okay, if we can go back to slides, back to number 1. Now, here's an example of a real easy API to be able to add to your website. Cortana integration actually takes just a few lines of code to make your app work with Cortana. So the first thing that you need is a voice command definition file. This is a simple XML where you define what you want Cortana to listen for. And she'll listen for, you could say, Cortana, make a connection with Shifter. And then she can open it up and she can pass you the activation object with the content that you had said to Cortana. And so after you have that VCD file on your website, you then will add a few lines of JavaScript to handle what you want to do when she activates your app. So you'll see here the first thing that I have is a feature detection. I'm saying if windows.ui.webui because I'm looking to see if that Windows object is there. That way, this code doesn't even run when it's used in a browser. But when it's loaded through the hosted app, it recognizes that object exists, and it'll run the code. And then if it is there, then I just simply catch that activation object, pull the parameters she's passing into me, and take some kind of action inside my app. So it's quite easy to add features like that to your native app. Now, one of the things that we're real excited about is the W3C standard that's the manifest for web apps. What the manifest does is it's a standard, very familiar object for us web developers. It's a JSON object that contains all the metadata about your web app. See, today it's tough to build hosted applications on all the platforms because there's a different approach for every platform. I just showed you how we made changes in the Windows manifest. Well, if you want to do a Firefox app, there's also a different manifest for them. Chrome has their own manifest. If you want to do it in iOS or Android, you have to use something like Cordova to polyfill that because they don't support them natively. Well, the W3C standard is bringing that all together. Web apps, hosted apps, installable apps can all use the same manifest. So you as a developer write to one manifest and have it work everywhere. So what we were doing in Windows 10 is we're adding support in the Windows Store to be able to submit the manifest for web app directly to the store and have that be your publishing agent to add your website to the store. All right, now I want to take a minute and I want to talk about 2 open source frameworks that we're working on that are inspired by Windows 10. Now, I mentioned the W3C manifest there, and the difficulty that we have in today's world building hosted applications. See, one of the great things about the web is that your web code already works across platform. So with Windows 10 being able to submit that cross-platform app to the Windows Store makes it very easy for you to get reach inside to Windows users. Well, we want to make it easy for you to do that for all platforms. So Manifold.js takes your website and creates a hosted application not just for Windows, but for all the platforms that support it. And when an application doesn't support it, we use Cordova to polyfill and create packages for those platforms as well. So let's do a quick demo here. If we can switch back over to number 3. All right, now Manifold.js is a Node application. So there's really 2 different ways that you can run it. The first thing that you can do is you can go to the website, manifoldjs.com, and we actually have a generator running on the website. It's a Node application, so it runs on the web, of course, where you can go and put in your URL, and it'll generate the hosted apps and deliver the packages for you. Well, you can also run it very easily command line by simply installing Node.js first if you don't have it installed, and then you do a simple npm install, and it'll install the Manifold.js and all the required tools for it. So I'm going to use the command line today, if you don't mind. And I'm going to paste it in there. And then I'm going to do a -l, the level, and debug so that we can actually see what's happening. Now, I already have a W3C manifest on this site. So it's going to go out and it's going to pull in the W3C manifest, look to see what resources that are attached, like images, and go and pull those in as well, and then build the packages locally. But if you don't have a manifest already attached to your website, it's okay. Manifold.js will build one of those for you so you can attach it to your website and use it later. So let's go ahead and run that. And you see it goes and it collects that information. And then it's going to build out each of those packages, putting the right images and the right content in each of them. All right. I'm going to run it one more time. I think I already had that created there. Okay. So now what I end up with is a different package for every platform. Now you might notice that this is something new for Microsoft. We realize that you as developers might be writing for other platforms other than Windows. I see a few of you dressed kind of like iOS developers. I think I see some horn rim glasses out there somewhere. But we realize that, and your code that's already cross-platform would be great to run in all the different stores. So some of the open source tools that we're building here is actually geared towards helping you be productive. We want to help you take that web code and turn it into apps, not just on Windows, but on all the platforms that you would want to reach your users for. So for Android, you see we have a Java application here that runs in Android. Chrome, we have the manifest that you submit to the Chrome store. We have the Cordova one. We have one for Firefox, iOS, the web one for you to attach to your website there, and the Windows 10 and even Windows 8.1. Now, along with those, we also have the instructions that you need to submit the app. So it tells you what store to go to, where to submit it, and all of those things as well, making it very easy. Now, you'll see what we actually created is that same type of package that we had just opened. Now, I'm going to go ahead and open that application here. So Shifter, and now we have it as a store app here. One of the things that gets difficult when you start building applications on all the different platforms is debugging across all those applications. So that's where the other tool comes in, because Windows 10 is generally great with debugging on the entire stack. We want to make it easy for you to debug across platform as well. So one of the things that we have here, you should see that show up, and then I'll open the Windows app again where we can see it. Now you'll see that as I open up different clients, you see those clients registering right here in the Vorlon dashboard. So this is a dashboard that you deploy out to the web, then you just add a JavaScript file to your page, and you're able to do cross-platform debugging. So you can see here, you can hit a button and you can identify which client it is. You can look at the DOM, you can see what features they support with Modernizer, and even do an Object Explorer to see what the DOM looks like for each of those different environments. Now, if I want to do something like, let's see here, this is number 1. If I want to, explore the DOM, it'll do highlighting for me and show what part of it I'm selecting and things like that. Now, Vorlon doesn't just work when you're running it on the same computer. It's over the web, so your devices can be anywhere. Now, I told you this is a cross-platform application. I already have this same application deployed on the iOS and the Android devices. So different devices in different locations, it doesn't matter. You can use Vorlon to then debug all of them at the same time from the same dashboard. Again, we're looking to build tools that make life for you as a web developer more productive, give you the ability to to create apps for different platforms, deploy them, and even debug them to make great experiences for your users. All right, if we can switch back to the deck there. So we're trying to build great experiences for you as a developer. Now, to find out more information about what we talked about today, you can catch these sites. First, dev.modern.ie will give you the latest information about what's going on in Microsoft Edge, the features that we're supporting, the features that we're planning to support in the future, and even some tools for debugging. The web platform, more information about that at dev.windows.com. We have a link there to reach information about Cordova and Visual Studio implementation, and then links for the open source tools, the Windows 10 inspired open source tools. And we'll tell you, we're strong supporters of open source at Microsoft. We not only create open source, but we use open source too. And I always recommend when I talk to developers, whenever you can, open source your code. Let someone else learn and build off of the work that you've already done. If you're not contributing to any open source libraries, or even if you are and you have more time, we'd love to have your help on the work that we're doing as well. So you can check out manifoldjs.com and vorlanjs.com to find out about the projects, get the latest versions of the code, try it out, and hopefully help us by contributing as well.